So for volume of a prism, you just do the area of the base, whatever that base shape might be, times the height. You can also find the surface area just by finding the areas of each of the faces and adding them together. For cylinders, it's also the same thing, area of base times the height. Since the base is a circle and we know how to find the area of a circle, that's pi r squared. We just do pi r squared times the height. For surface area, you're adding the areas again of all the faces. The two circular faces are each found by doing pi r squared, and since there are two of those, we have 2 pi r squared, plus the surface area of the curved piece, which if we unfold it, has the height of the cylinder, and then the other piece around is the circumference, so that's 2 pi r h. Also, with both prisms and cylinders, if you slant them or tilt them or kind of do weird things that way, it still keeps the volume the same. It will change the surface area, so you can't do the surface area the same way, but the volume will be the same. For pyramids, they have the apex, which is the point at the top, and then the base, and then all of the triangular pieces that go up and meet at the apex are called the lateral faces. So the lateral surface area is the area of all of those lateral faces added together, all of those triangle pieces added together, not including the base. The surface area, just the regular surface area, has all of those lateral faces, the lateral surface area, plus the area of the base. You're also going to want to make sure you know the difference between a slant height and then the regular height within a pyramid. The slant height is the height of the triangles, but the regular height of the pyramid is perpendicular from the base to the apex. For the volume of a pyramid, it is 1/3 area of the base times the height. We saw that the volume is 1/3 of the area of a prism. So you just do 1/3 area of the base, whatever that shape of that base is, find that area, and then multiply it by the height. Make sure you're using the height of the pyramid, which is perpendicular from the base to the apex. It's not the slant height that goes along the side. So now we have a cone. Volume of a cone is also 1/3 area of the base times the height. But since we know that the base is going to be a circle for a cone, we can do 1/3 pi r squared times the height. For the lateral surface area of the cone, if you kind of unroll the cone, you can see that it's just a sector. So you'd find the area of the sector. If you do that in radians, which we haven't talked a ton about, you end up getting this formula that simplifies really nicely into pi times the radius times the slant height of the cone. So that L is standing for the slant height. If you want the regular surface area, not just the lateral surface area, you add that lateral surface area, pi rl, plus the area of the base, which is a circle, so plus pi r squared. So you'd get pi rl plus pi r squared for the total surface area of a cone. For our last solid, we have the volume of a sphere and the surface area of a sphere. Volume is 4/3 pi r cubed, and surface area is 4 pi r squared. So all you need to know for a sphere is the radius, and you can calculate the volume and the surface area.